If you have any doubt, then you can ask me. But if you don't have any doubt, then I'm going to start new topic, that is a supervised learning. And in this supervised learning, what we had to see, the new topic will be identified by the logistic regression. As we know, how many regressions we have seen? We have seen the linear regression, multiple linear regression, we can say, and we have seen the polynomial regression. And these are the various flavor we have seen. And now we have seen the decision tree. Decision tree is a model in the machine learning. It works for the regression as well as the classification. When I talk about the regression, then the data would be in form of the continuous nature based. But when talking about the classification, so data nature form would be from the categorical. So in the logical regression, what we have the data representation, a data on which we have the categorical kind of the data. So on that, this kind of data, we will work, and that is time. And at the time, we have an important regression that is known as logistic. So logistic regression basically is what this is a flavor of the regression, but here the data will be in form of the from the categorical base. So that's why we can say the logistic regression problem or logistic regression to be used to solve the problem of the classification. But what is the aim of the logistic regression? Just let me clear over here. The aim of the logistic regression is to predict, to predict. But what we predict, of course, as our required information, so we predict. So if you're saying that we need to predict something, so here two important aspects is required: dependent and independent variable. So when we're talking about the independent dependent variable in the regression, normal regression, what we have the data in form of the non-discrete nature, or we can say continuous nature based. But when talking about the logical regression, the data form will be in form of the, or a data nature will be in form of the category base, on which we need to decide our decision, or we need to decide our prediction, and that is our beauty of the logical regression. So from these words, I'm going to start what is mean by the logical regression. So here we have some idea of the regression. So no need to discuss more about detail about the regression. What is mean by the regression? We have already seen. And regression analysis is a powerful statistical analysis technique as we know. So we are not worry about the various kind of the aspect or other kind of the things. And as we know, a dependent variable is also known as the target variable, response variable in the regression, of course. And we're talking about the independent variables, which is also known as the predictor variables, or we can say it is also known as features on which the data will be, or the our outcomes will be decided. So this part we have already seen. But when talking about the logical regression, so it is a kind of the, it is a flavor of the regression, and the purpose of logical regression to analyze the prediction on inform the outcome, and the data nature or data form will be informed the two way, that is we can say category based. So one way we can say category based, or we can say one we have the category based. So or classification. But when talking about the category or classification, so how we can decide? So what is the form of data that is necessary? So if I'm speaking again categorical type of data, so what does it means? It means we have a data in form of yes or no, true, false, or 0, 1. So when I'm saying you want to go to market, then you will say, sir, yes, I will love to go to the market. But you have the two options. If I'm offering you can go, you can use my car to go to the market, then you will say, sir, yes, I will go. But I'm saying to you, okay, you can go to the market, don't worry. But I'm not offering any vehicle. Then you have to go by foot. So how it is possible? You can go, but you will not like to go. So you will say, sir, no. So you have the two options. Either you like to go to the market or not. So what parameter we are deciding this thing, that is known as a feature. So if on the basis of feature, if we are choosing or we deciding something, that is a decision yes or no, or true false, or 0, 1 category, and that is to be identified by the our problem. That is problem is known as the classification problem. And here we will see that problem by the help of the logistic regression. Okay, so from this point we are going to start more detail about the logical regression in a specific manner. Here we have a term, what is a logical regression? As I told you so many times, logistic regression is a classification algorithm. and it is used to when the value of the target variable is category in the nature. The point you need to keep in mind, the dependent variable and target variable value should be categorical manner. Just like example of the student who have the age greater than 30, so the value should be 0. A student who have the student is less than 30, the value should be 1. So on what parameter I am deciding this category, yes or no? That is based on the age. So age is a feature, and this age is also on the independent variable or predictor variable. So but what is the my dependent variable? That is a 0 or 1. So what is my value? I'm getting 0 1, and that is my part known as the student status. That is, if the student status belong to 0, so we can easily identify that student is less than or greater than 30. So based on this concept, we can understand dependent variable should be in form of the categorical, and that is the point you need to keep in mind while learning the logistic regression. So logic regression is mostly commonly used when we have the data and the question has the binary output, like 0, 1, yes or no, true, false, as I told you. So the point you need to remember here is written over here in the decision tree. Decision tree also supported by the two approaches. One is the regression classification. And we have seen what is meant by the decision tree and what is the drawback of decision tree. But when we need to think about the logical regression, so logical regression only support the classifications problem. So the classification, if I'm saying again, so classification task when we need to do perform any by the any algorithm, so data would be informed the discrete category, and that is the point you need to keep in mind, just like 0, 1, true, false, or yes or no, and that is the important point. But in the case of the regression kind of a task or regression kind of activity, you have the data in form of the continuous nature base, and that is my point you need to keep in mind while learning logistic regression. And today we will see theoretical part to learn more detail about the logical regression. And thereafter, in the next class or tomorrow, we will have the practical. Practical is very interesting practical, and it is necessary to understand the humanity. Okay. So, do you have any
Yes,
doubt right
sir.
now? Yes, tell me.
Sir, in the linear regression, if we have one column as countries, we have two countries. One
Okay.
is India and another one is US.
Okay.
For that, directly we can mention 0 as India and US as 1.
Yes, of course, and that is the point. See, in the country we have the two options only to represent the student, India or USA. So we have the suppose we have the 10,000 students, and this among the 10,000 students, some students belong to Indian country and some students belong to USA country. So we can say the country features or this country column is also identified by as a dependent variable, and the information which is represented by the 0 1 form, of course you can choose, no problem. So India we can represent by the 0, USA we can represent by the 1, and that is known as
Yes.
the classification of data. So based on the country feature, we can classify the data. How many students
Sir,
belong
at
to
that
USA
time,
country?
sir, at
Yes.
that time in the linear regression only we are using classification, no, sir.
No, no, no,
Why?
no, 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 no. See, this is the point. In the linear regression, keep in mind in the linear regression, you are solving the problem, and you are solving the problem based on the linear approach. That is the point you need to keep in mind. But in the logic regression, we have the problem in the non-linear way. That is the point you need to keep in mind in the mathematical. So we are in the linear regression, we have only two countries just like India and USA. So you can take this part, but the question comes in our mind on what parameter you are classifying. So you are not classifying, you are predicting, you are assuming something based on the input, what input you will give. But in the case of logic regression, you have to classify the data. So based on the India and USA country, you are classifying the information. That is my point. But in a linear regression, you need to predict something on based on your linear approach. That is my point. But in the logic regression, we don't have a linear approach. We have the non-linear approach. That is my point.
Okay, sir.
Okay, so that is an important difference we need to keep in mind while learning the logic regression and linear regression. Okay, now see, you can see this image. Now this image has lots of the words, then you can understand. The linear regression, what we are doing, we are predicting the our information based on the 0 and 1 range if you have the some range. But the value we are predicting, we are assuming in the logistic regression that either could be 0 or 1. Suppose I am solving a problem and my value should be 0 and 1. So if I'm predicting something like 0.3 and 0.4, and that is to be considerable here into the linear regression because I'm predicting something. But in the logic regression, I can either choose 0 or 1. That is my point. So the information we have in the linear regression in the continuous manner. In the logic regression, we have the information from the discrete manner. That is the biggest difference. I will come on this image, but just let me know this important point. What is mean by the logic regression? Is it clear? The introductory part about the logic regression is clear?
Yes, sir.
Okay, good. So any student who have any doubt to understand the logic regression, the introductory part of where we can use the logic regression?
No doubt, sir.
Okay, good. So now I'm speaking about this image. As I told you, logic segregation is basically a machine learning model, and which is used to classify your data and see. We use the classified data in the logic regression to predict something. Like I'm taking a simple example for the betterment, then you can understand. Suppose you got a marks in your subjects: subject one, subject two, subject three, subject four, subject five. From this point, I can say if you are having something, marks 1, marks 2, marks 3, marks 4, these are the 5 different marks of each and every subject. If you are crossing marks more than the, or we can say the more than average, if average is more than the 60%, then you can move to the next semester, as you have to stay over here. So I can put the next column, that is your decision column, or that is also known as dependent column or dependent variable column, which defines your status. You can move to the next semester or no. So I can say yes or no, or I can write 0 1. So what are the features on which I can decide based on your marks? But in the linear regression, if I'm assuming this thing, so my data that is to be known by the decision column or decision variable, that will be represented by the non-discrete manner. The range could be anything. So here, but in the logical regression, my data, the information that is decision column, or we can say the dependent variable column, will be identified by the information of the 0 and 1. And that is a little bit different. You have to keep in mind. Why? Why? Because in the logical regression we have the non-linear approach, but in the linear regression we have the linear approach, but in the logical regression we have the non-linear approach. So how to identify the linear approach? Of course, y equal to mx plus c, and that is the equations on which we can identify or we can solve the problem linear regression. So the what you need to keep in mind, predicted y can exceed 0 and 1 range. Okay. But in the logical regression, you can predict the y lies within the 0 and 1. So the option you can choose either 0 and 1, but in linear regression, we can choose any option from 0 to 1. So it could be 0 0.1, 0 0.2, 0 0.3, 0 0.4, and so on, so 0.9. And that is a big difference you need to keep in mind. So in the logic regression, let me explain the diagram carefully, then you can understand. I'm taking a real example, then you can understand in simple way. Suppose you need to go to the market. Okay, you are looking for to go to the market in somewhere else. You have the two options, as I told you. Either you can go, or either you can not go. So y equal to 1 is written displayed over here, and y equal to 0 we are assuming. So you have the two options. On the based on the independent variable, you are choosing the your decision. But finally, somehow we are getting something value like y equal to 0.3. Based on the some input of the x in the logic regression, we are getting the value 0.3. So in the logic regression, as the definition is saying us, you can choose either 0 or 1. So on what parameter I can say which value I should choose, 0 or 1. So the thing we need to keep in mind here, we have an important term that is known as a threshold value. And threshold value by default we can assume in the middle value. So here I'm assuming middle value is 0.5. This 0.5 is what? That is the threshold value. If my output value, that is y value, which was a 0.3, if it is less than threshold value, so we can predict the our information that lies on the 0. Else we can predict that information based on the our line y equal to 1, so we can assume 1. So I'm using any different color pen to explain my concepts. Let me explain. Suppose based on the x input, and we have some input, I'm just question mark over here, and based on this x, you are calculating something y, and you are getting some value of the y 0.3, and this is a threshold value, and that is the mid value. I'm assuming right now this is known as the threshold value. I can write over here. This is known as the threshold value. Threshold value. Okay. And now see what is the value I am getting? 0.3. So 0.3 is, you know, 0.5 is your threshold value. Okay. And that is a 0, and that is a like this. So if the value which is greater than threshold value, so we can put into the 1. So we can put over here, else we can put over here. So definitely we know 0.3 value is less than the 0.5. So definitely what value we choose for the prediction? 0. So we can assume that is the point. You are not going to the market. That is my point. So we can divide our information to different class, or we can say two different groups or two different uh, cluster. So what we are having, we have the groups. So on what parameter you are grouping? That is a value. That is threshold value, and this threshold value will list. But normally, the threshold value will be identified by our prediction variable. The logistic regression function will decide automatically in the Python programming, and that is a good and best beauty of the Python programming. We are not writing any special code. We will just call the specified or predefined functions or methods in the Python programming, and internally the algorithm of the functions of the logistic regression will do internally automatically each and everything. So we will not mind to write the code, especially this one. That is a good thing. We will see how it is happening practically. Don't worry, we will see. But here I'm just introducing about the logical regression concept. Now tell me, any doubt over here?
Excuse me, sir.
Yes, tell me.
Sir, you're taking linear regression and you're finding the y value. After that, you're finding y value. If you get the threshold value, if you the value of y is more than threshold value, then it's going to be 1. Less than threshold value, it's going to be 0. That is
Yes,
called logistic regression.
that is under come to logic regression. But in the linear regression, your value can
We are
be
not using threshold
zero.
value.
Yeah, we are not using any threshold value because on
Here
what
we are.
parameter? Yes, this
Yes,
is my
sir.
point. Yes, tell me.
Sir.
Yes, tell me. Yes, yes. Yes, tell me.
If we use threshold value, then it will enter into the logistic regression. If not, linear regression.
Yes. See, why we are choosing this threshold value? We are choosing this threshold value because we are getting the y value 0.3. That value we will not accept. This value in form of the continuous manner. Okay. And how you can accept this value? Now tell me in the logical regression. So we will accept the value that should be belong to the categorical form. So either we can choose 0 or 1. So what parameter you will decide the value should be transformed into the 0.3 into the 0 or 1, and that is known as the threshold. So threshold, the concept we describe, you will move either 0 or 1 based on the threshold part. So but you can't take the 0.3, you can take either 0 or 1. So we are defining a borderline. This borderline becomes the threshold value, and you're crossing the border, you are crossing the value more than the borderline, then you can choose the upper part, as you can choose the lower part. So lower part can be identified by the 0, and upper part can be identified by the 1. That is my point.
Okay, sir.
Okay, but in the linear regression, threshold value is not applicable because we can choose any value, like I can write over here. So you
Sir,
can say,
I wants to say one thing, sir.
yes, please.
If my robot will be trained with linear regression,
Yes,
I'm asking that one question to that. You
yes,
have to go to market.
yes.
Then outside is very rainy and no vehicle. Then it
Mhm.
will be thinking if I have to go or not. If it will give y value as 0.6, then it will be confusing. But when we trained with a logistic regression, it will be directly entering to the 1, and it
Yes,
means I
of
have
course.
to go
Yes, yes. This is a
like
good
that.
point.
Like that.
Yes.
Like that, we have to train for training the accuracy answers. We are using logistic regression, right?
Yes, yes. So logical regression is applicable where you have the decision either yes or no, or no, true, false, or 0, 1. So because you are classifying your data in the two options only. Right now, I'm speaking. So that's why logical regression is better. But in the linear regression, you are getting the value 0.5. So now your machine will confuse which decision should be better. So definitely the accuracy in the logical regression is better when in case of the classification. So classification in the linear regression and multiple linear regression is not applicable because here you are just predicting the information. So you are based on the continuous kind of the data. You can try to predict something based on the categorical data. Definitely, the accuracy of your model will be low. So that is the problem. What kind of data we have on, and according to the problem, we will choose the appropriate model. So first, you need to see what kind of the problem you have and how you can solve the problem because not logic regression is not a single model. We have the various model. But right now we understand the logic regression model to classify your to solve the problem of the classification, and that is my point. So if you're talking about the robot example, your robot will see, and after calculating something based on the features, robot calculating the value 0.7. So now we have the machine, we define something in the threshold value in the algorithm for robotic manipulations. So robot just identify now value is greater than or smaller than. Okay, the machine identify the value is less than or more than, but machine identify it is value is greater than. So machine will move, and sometimes found that sometimes with this threshold value some decision may be wrong, but it is a machine thing. So we can say the no model in this world is the perfect model. If you are getting the accuracy of the 100%, so that is the only the limited data you're talking, but we have a huge amount of data set, so no model is perfect. No model gives the 100% accuracy. Even you will get the accuracy 99.99, so it means there is some error 0.1. So we can say the model in this world, we have any model, a real life model is not a perfect model. That is my point. Sometimes more based on threshold volume or model robot decided should be moved, but suddenly found that there is a some dig. There's some space which is not in the surface, or we don't have a plain space. Suddenly, robot will fall down. So that is the point we need to keep in mind. So at the time, sometimes it may happen. So decision will be taken care of all the features. So we will not take the decision based on single feature, single independent variable. The machine will take the each and every thing carefully. So I'm talking about the robots. So first, robot will take the input from the camera, inform the vision. Robot will think, robot will send some information, and robot will observe each and everything. So the machine will take many features, and each and every feature will be interpreted into the numerical value. And based on the numerical data, the machine will decide each and everything. But the internal computation will take some time. And after taking the calculation, machine will take the decision. Should we move to ahead or not? That is the matter. Now, is it clear?
Yes, sir.
Okay. So if this diagram is clear, then I can move to the next slide. And if any other student who have any doubt, you can ask me. Yes, tell me. Any doubt?
No doubt, sir.
No doubt. Good. So I'm just again back to my logic regression concepts because as I told you, today we have only theoretical aspect and we will see theoretical aspect of the logic regression. But still we have a questions, and of course we will clear each and every questions by the slide by slide. So here again we have the same things. So we will not spend much time to discuss over here more and more about the logic regression. But it is written over here that independent dependent variable is also known as the target variable, response variable, and the information of the dependent variable will be identified by only the categorical manner, and this category can be identified by the binary like 0 1. So what kind of the information it has? Binary kind of information, because it is represented by the 0 and 1 only, true or false only, yes or no only, because we have the two possible outcomes. That's why the representation of the data will be form of the two way, 0 1, true false, or yes or no. So that is time we have the two possible outcomes. Okay, so dependent variable will contain only two possible outcomes. As I told you, yes or no, true, false, or 0. So that is the point we need to keep in mind. But when talking about independent variable, this independent variable also known as the features, predictor variables. Okay, and that is the point we need to keep in mind. So here we have written the statement which describe the important aspect. In the dependent variable, will should or always should be followed the categorical data in the logistic regression model. That is the method. And after understanding this point, let us understand this point here. It is written over here. Logistic regression is a special case of the linear regression. And in the linear regression, we need to predict something. So same thing, if I'm speaking of again here, I'm speaking here, please listen carefully. In the linear regression, what we have done, we have predict something based on independent variable, dependent variable. Based on dependent variable, independent variable. So this is the point we have seen. In the logistic regression, what we are doing, we are also predict something based on the dependent variable, independent variable. But the point we need to keep in mind, the dependent variable should have categorical data. And that is the biggest difference you have to keep in mind. So we can say it is an extended version of a linear regression, or logistic regression is an extended version of a linear regression followed by the categorical kind of the data. And of course, in both kind of the regression, we need to predict something, and that is the more important part. So here, what is the important things on which we can decide, and that is that we have the log function. This log function basically mathematics is saying to us the log function is a function which describe the your logic on what parameter the machine will choose or the system will choose, or our outcome would be 0 or 1, and that function is known as the log function. Okay, so that is the point we need to keep in mind. So your probability will be 0 or 1. Your probability will be two-way, and that is to be defined by the some function that is known as the log function. Here log function means I'm talking about the logic function, which is known as the logic function. So sometimes you can find this is also known as a logic function. I can write over here. You can find this word over the internet or some books. This is also known the logit function. Okay, and that is something you need to keep in mind. But what is the function on which we can decide the value of a dependent variable? In a linear regression, we have seen the equations y equal to mx plus c. In the I can write over here. In the linear regression, we have seen the equation of the y equal to mx plus c. Now, am I right? Just tell me, am I right?
Yes, sir.
In the multiple linear regression, we have the many independent variable like x1, x2, xn plus c, and each and every variable will contain its own coefficient. So I can write like this one, m1, m2, and so mn. So this is a definition of the, or this is the equation of the multiple linear regression. If I'm putting the degree of the linear regression or the multiple linear regression, so what I have the polynomial regression. So there is no need to worry about this kind of equations we have seen. Like I can write over here for a betterment, y equal to m1 x1 square, or I can write m1 x1 and plus c. So this equation can be identified as a polynomial because we have the only one independent variable, that is x1, and we have the 2 degrees. So when we introduce a degree with our equations, with the line equations we can say, and that is identified by as a non-linear data pair. So our information will be represented by the non-linear way over here. In the case of the, we can represent information in form of the linear. But now question comes in our mind, what is the function in the logic regression? How we can decide the y value? Here we need to introduce a new function that is known as a sigmoid function. And this sigmoid function will decide the value of the y, and that is independent variable. So as I told you, the y value should be 0 or 1. Because in the logical regression, either you can choose 0 or 1. You can't choose any value 0 to 1 range. You can choose only value 0 and 1. And that is the point we need to keep in mind. This is the most important point we have to keep in mind. So what is a function? How we can define? How we can decide this point? So there is a function that is known as the sigmoid function of curve to predict the categorical value. So how to predict? So definitely, what is the value of the y? As I told you, suppose after calculating something, we are getting the value of the y, that is 3. So so what we have to do? So if you are choosing the value of the y equal to 0.3 and we have decided threshold value, if value is less than threshold value, so the final value of the our y would be 0. If it is more than the our threshold value, so we can define the final value of the y 1. And that is the point we need to keep in mind. So Sigmoid function is a function which describes your important part of the choosing the final value either 0 or 1. And the threshold value will decide the outcome as it is written over here. The threshold value will decide the outcome. That is, you are choosing the yes or no, win or loss, 0, 1. That is my point. So far, any doubt, please you can ask me right now. So far, you have any doubts, please you can ask. Just one tell me, so far you have any
So,
doubts? So everything is clear so far we have discussed about the
yes, sir.
logic. Okay. Any doubt you can ask me? No doubt?
No, sir.
Okay, good. So here we have some terms we need to keep in mind, and so this is only theoretical purpose. So we can call a logistic regression a linear regression model, but the logistic regression use a more complex cost function. This cost function can be defined as a sigmoid function. So what is the function by which we decide the cost? We will decide the each and everything of the logistic regression by the sigmoid function. So in the linear regression, what we have decided? In the linear regression, we have decided our equation that is y equal to mx plus c. Okay, so this is the point. So mathematically, internally, each and every model in the machine learning is introduced internally. So we are seeing only the basic mathematics. We are not looking at the, or we are not seeing at the hard and tough mathematics. The fundamental mathematics we are only following, and that is a very small concept which is following by to interpret our information. So the point you need to keep in mind, the logic regression model can be complex based on the its cost function. That how we can decide. Okay, so this function logic symbol function is also known as the logistic function. So in the sometimes when you heard or when you believe to listen this word logistic function, so you will get confused of what is the mean by the logistic function. No, logistic function means sigmoid function. We are calling the same name. So only the naming convention you can say. So in the linear function, what is the linear function? In the linear function, we have the y equal to mx plus c. In the logistic function, we have the different equations. I will tell you in the next slide we have. The hypothesis of the logistic regression, how to determine? Yes, of course, as I told you, the hypothesis or AX value, hypothesis or your logistic regression can be easily identified. That should be ranged from the 0 to 1. We can choose, but we will choose only one value, either 0 or 1. So that is the point you need to keep in mind. This h theta x is basically hypothetical value, and this can be identified as a threshold. In simple word, you can understand this hypothetical value or hypothesis of the hypothesis this theta hypothesis of this x variable, just like threshold value, and that is the point. So if we are getting this value, so we can say we represent only two values, either 0 and 1. So as I told you over here, I'm moving back to already told you here about the concept. Okay, so that is my point. Here we have the threshold. Yes, here we have this. Okay, so that is okay. So after this point, still we have a question. I'm speaking again. Sigmoid function is a known as a logistic function. Is the better tool, better function by which we can decide the value. But what is a sigmoid function? So in the next slide, this term we have. But before jumping to next slide, just let me know. Do you have any doubt? Any student who is just having any kind of doubt? Please, you can ask me. Just please tell me if you have any doubt. Please, you can ask me. Just student, tell me any doubt you are having.
Sir, it's all out. If we get 0.5 as a y value, then what will be?
0 point.
entering into the 0 or 1.
Suppose now first tell me what is the threshold value. First tell me. I can solve your problem. Now tell me what is the threshold value you are deciding. Just I'm taking the t is the threshold value. Just tell me your threshold value should be 0 and 1 only. Now tell me what is the threshold value you are choosing. Now tell me. Tell me any value between 0 and 1.
Sir, it's 0.5.
That is a middle value. Okay, I can accept this value, but if you want to change, just tell me you want to change.
No, if we change, definitely I'll get. If it is more than 0.5, it will be entering into 1. If less than 0.5, it
Yes,
will be
that
entering
is the
into
point.
0.
Yes, good, that is my
Then
point.
what
Suppose
about 0.5, sir?
0.5, this is the point. This is a good point you are asking. Suppose we are getting the values y equal to 0.5. So you can first at a time you need to decide. By default, the 0.5 will be considered into the 1. That is my point. Why? Because in the normal case, we will write our this equation like this one. Okay, this value 0.5. This value threshold value. Suppose we are getting any value which is lies on the zero threshold value, so that will be considered as one. So by default, it will be considered. It is just equal to understand the concept of round off. Very frankly speaking, in the general way, I can understand internal policy of the algorithm. Suppose I'm choosing or I'm just getting the value 0.4, so round off the value would be 0. If I'm getting the value 0.5, so round off value would be 5. Round off value will be the 1. That is point only. The most of the people or most of the concept will understand this point. But depend on the problems we can define. Depend on the problem we can define. But in the Python programming, we will not bother about such kind of things. It internally decided, and without the any explicit function or any internal function, we will define our own function to calculate to determine the threshold value. Don't worry, and that would be our next exercise. But that would be not next exercise. Next to next exercise. First exercise would be as a lab activity or lab exercise would be the implementation of logistic regression, and thereafter we will see our next practical to determining the this function, that is Sigmoid function. Sigmoid function is most usual function in the neural network. So we will now focus on the Sigmoid function deeply. But what is the equation of Sigmoid function? That is my point. So we have the next slide where we will see. But before that, let me clear. If we are getting any value which are 0.5, so it's okay. We have decided threshold value, and there is a guarantee we will get the value 0.5 exactly. May we get the value 0.5 4, 3, 2. So suppose we are getting this value, and this value definitely, this value will be definitely more than the 0.5. So definitely we are getting the value 0.5432, which is a greater than the 0.5, or we have the decided threshold. So definitely we will put into the 1. That is my point. Okay, so that is my point only. So there is a guarantee you will get exact 0.5 value. No, maybe you can get the value 0.5432. So definitely this value has a more weight than the this threshold value. So definitely we will consider into the 1. So that is the reason when we are having any value which are close to the, or we exactly we are getting 0.5, so we will consider into the 1. That's the main reason, and this is only the technical reason. Okay.
Okay, sir.
Okay, so now it's time to see what is mean by the Sigmoid function. So as I told you so many times, sigmoid, sigmoid, sigmoid. So what is this sigmoid function? So let us understand this sigmoid function properly. And whenever you have any doubt, then you can ask me. In order to map the predictive values of the probability, of course, to the probabilities we need to see, we use a sigmoid function. And this sigmoid function will determine the value 0 and 1. It will not decide any values between 0 and 1. It will decide value only belong to the 0 or 1 only. And that is the point we need to keep in mind. We have the word, okay, we have word 0 and 1. Okay, so sigmoid function will return any value between 0 and 1, but we will choose only one value with a 0 and 1. So as I told you, how we'll get the sigma, how we will receive any value between 0 and 1, was like this one. Suppose we are getting the y value 0.5432, and this value is lies between 0 and 1, but we will choose only one value, that could be 1 or 0. How we will decide? Based on the threshold part. Okay, so in the machine learning, you use the sigmoid to map the prediction to probability. And here I'm just remembering an example. After many manipulation about to applying the various features, now you have decided you are getting the value. If you are getting the value 1, then you will purchase a car. And if you are getting the value 0, it means you will not purchase the car. So you have the two options, either purchasing a car or not purchasing a car. So after following the many features and putting the values in the logic regression, we'll get some values, and prediction we are assuming we are getting the some values like 0. So the our model is saying to us, on the basis of your inputted features, now you are not able to purchase a car. Now, if your model is giving the output of predicting something, that is we are getting the value that is 1, so we can say our model is saying to us we are able to purchase a car. Now what would be the features of the purchasing car? Budget, okay, monthly income, okay, annual incomes, okay, and your space, and so many features you can decide. Okay, suppose you have in your house there is no space, so some space required, so you will not park your car on the road. Okay, so there is a risky. So definitely there are so many features on which you're deciding you will purchase, you will able to purchase car or not. That is my point. Same thing, sigmoid function will determine any value that could be lies between 0 and 1. And but we will choose only, the model will choose only one value based on the threshold parameter. So overall, the representation of sigmoid function will give the its graphical manner. It will look like as a S shape, like you can see over the screen, S shape. So that's why the name is given as a sigmoid, because we will have the S shape we are getting. So it look like this S-shaped curve when we need to see on the graph. And value definitely would be between 0 and 1, but we will draw only those value which are close to the or less than or greater than the threshold value. So that is the point we need to keep in mind. Here we have an example by which you can see. This is the example. First, let me explain this example, then I will tell you what is the equations of the sigmoid function. Now, this example is visible to all. Here we have the two graphs, one graph and second graph. I have separated these two graphs by a line. Now it is visible to all. Just tell me, is it visible?
Yes, sir.
So in this graph, first look at the second number graph, and because we have the space right now. So this in the second number graph, where you can see my pointer, this 0.5. Suppose we are assuming 0.5 is threshold value. That is my point only. You can assume, but by default you are not assuming. So the machine will decide on automatically 0.5 middle value as a threshold value. You can see this point belong to the -8. Suppose we are putting the value x is equal to -8. So we are getting something value y. This suppose we are getting the any value like x1 value. This x1 value is the value after calculating we are getting. This value is less than, this value is less than threshold value. So we will plot our point on the line, this line. So we have plotted this point. Same thing it will happen with the other points as well. Now you can see over here. There's so many points are drawn or plotted over here. You can see. Same thing, the value of the value of the some predictive value or predictive features we are getting the positive in the one way. So it is plotting on the this point. Now you can see over here. There are so many values are plotting, and definitely don't worry, as by practical I will show this diagram how it is happening. Each and everything will I will show by the practical session. You will be happy to see the answer. So what is a step we can say? I'm just, so you can say this is the line, each and every point which are plotted on the line one. So it will be look like this one. So for explaining purpose, I'm just showing like this. And now it will be drawn over here like this. Okay, so all the points. Now, if these points, these drawn points, and connecting by touching the threshold point line, and to this point, it look like as a S. Okay, that is the main reason. That is the main reason. It look like the as a S. I'm just drawing. Okay, like this. That is a minor. Okay, these all these points would be on the line 0, and these all points would be on the line. So no point will be plotted in the or on the this graph on the 0 0.1, 0 0.2, 0 0.3. So that is a my point. You can see none of the point is plotted on the 0 0.1, 0 0.2, and 3 and other so. And these are the plotted on the 0 or 1 only. So this is the example. Now this sigmoid functions graph is clear to all. How we are identifying it is represented by in form of the S shape. Now it is clear.
Yes, sir.
Okay, and
Yes.
definitely don't worry. I will tell you. I will calculate the various values of the buy, and we will plot each and every value of the buy over the our graph. Then we will see our output will be formed as a as shaped. Okay, that is the point. Now here, if we're talking about the sigmoid function, so in the linear regression, we have a straight line equations. So straight line equation will be the useful equation by which we can solve our problem in the linear regression. In the logistic regression, we have used the sigmoid function, and this function is known as the logistic function. So what is the equation of the sigmoid function? So here we have this equation. So if you're talking about this independent variable, so y equal to 1 upon 1 plus e to the power x. So we can write this equation y equal to 1 upon 1 plus e to the power x. And this e is an exponential and which contains the value 0.271828. There is a different value, you can keep it in mind. So we have this point. And x is our, x is what? X is our independent variable. And that is the one variable we have. So this equation is only sufficient for when we have the one independent variable and one dependent variable. But of course, the point you need to keep in mind in any regression or in any classification approach, we can say right now. So in the regression, there would be only the one dependent variable, but independent variable can be many. So if anyone tell you or if anyone try to change your idea, can we have the two independent variable? No, it would not be possible in the regression. In the regression, only the one independent variable will be applicable only. Yes, I agree. Independent variable can be many, but dependent variable would be one. That is the point you need to keep in mind. So if I just need to write this equation by the different or number of the different independent variable, so I can update this equation like over here, like y equal to 1 upon 1 plus e to the power x1, x2, x3, and so on, so xn. So what I'm doing, I'm just solving this problem by the multiple independent variable, and b1, b2, b3 are respective its coefficient. So I can write this equation by the multiple independent variable. But this equation that is above, which is written into the dark manner, y equal to 1 upon 1 plus e to the power minus x, that is sufficient equations. So we will not bother about the other thing. That is sufficient equation, and it is more useful as a more and more useful sigmoid function by which we can calculate each and everything properly. And that is an important point we need to keep in mind. And this function is solved or sigmoid function can have an equation that is known as the sigmoid equation. So this equation is also known as the sigmoid equation, and which is written over here 1 upon 1 plus e to the power x. And what is e? Exponential. What is x? Independent variable. What is the y? Dependent variable. If we have the multiple independence, so we can write our equation like over here and then here. So you can utilize each and everything properly. Okay, so that is my point. So this was about the sigmoid function. Okay, so tell me any doubt in this point. Do you have any doubts? Please, you can ask me. Yes, friend, tell me, do you have any problem?
No, sir.
No, sir.
Okay, so far just let me clear to all once again what we have discussed. We have discussed what is mean by the logistic regression and where we can use the logistic regression. And next step we have seen how logistic regression is more applicable in the classification problem. And we're talking about its value, where it lies. The value of the regression, logistic regression lies between 0 and 1 only, but not lies 0 and 1. We can choose only the two options, either 0 or 1. So it's up to you or depend on your threshold value. So how to determine the various values of the y? So how we can say the value of we are getting from 0 and 1 only. So that is Sigmoid function. So Sigmoid function always return the value between 0 and 1 value. And that is the point you need to keep in mind. And suppose we are getting any values in the negative and positive, negative or less than 0 or more than the 1, it means you are doing some mistakes in the calculation. So that is the point you need to keep in mind. The value of the sigmoid function always written between 0 and 1 only. And that is my point you have to keep in mind. And this is our graph we have seen. So here we have the one graph and second graph. So one graph we just replica of the second graph, but second graph I have just left blank due to explanation purpose, and that is a necessary part. So this gives a value by that is extremely close to 0 if x is a large negative value, x is a large negative value close to 1. So that is the point even as we have seen through the example, as it is written over here. After the input, new input value has switched toward the 0 and 1. So input value can be run through a typically linear function, but input can now put into a distinct category. And that is the point we need to keep in mind. You can get the y value from 0 and 1, but you can choose only one value that should be 0 or 1. So the classification is mean what prediction you are assuming. You are assuming you are getting the prediction based on your y value and based on your important aspect threshold. So if we decided the value is more than this our boundary line, so we will opt this point, or we can move to or else we can move to the another option. That is my point. Here we have an example. Here we have a simple example about the sigmoid function. So you can see each and everything will be drawn over here. Now, see, these are the two different examples. One example, here we have written over here z equal to some, so yeah, sorry, sigma z. So sigma z is equal to 1 upon 1 plus e to the power minus z. This minus z will contain the some value, and after putting some value, we will get some value between the 0 and 1. Sigmoid function will return the value 0 and 1. But what is Z? Z is basically is a collection of the various points like weight and its input and some biases. In the mathematically, we have to add some additional value that is known as the biases. This concept can be identified into the neural network. So when we discuss about the neural network, in the neural network, the sigmoid function is most applicable. But now question comes in our mind while seeing this approach, where we have to use the sigmoid function. Now see, this is our point, and this is connected to this point, and this is connected to this point, and this point is connected to this point, and this is connected to this point. So what I am drawing over here, these are basically some neurons in our mind. So whenever mind will decide should we go to the market or should we do this activity or not, should we move to here or not. So how will take the decision? That is the followed by some activation approach. So that is why the biological. But when talking about the mathematical, so what is the function on which the neuron will be activated? And that is point we have the activation function. So in the neural network, in the mathematical neural network or the machine learning neural network approach, the neurons will be activated by the some activation function or some function which are known as the activation function. So when neurons are activated by some function, at the function is known as the activation function. Sigmoid function basically is the most important example of the activation function. Why? Because it gives a value between 0 and 1, and based on your threshold, you will decide to choose 0 or 1. That is my point. Suppose I have decided the threshold value is 0.7. I am taking real life example in the threshold. In our university, I have decided the percentage of the student is more than 90%, then student will able to take the admission over here. So what is the value of the percentage? 50 to 100. The student who got the marks more than 90, they will get the admission, as their admission will be rejected. So what is the you are doing? You are classifying your data rejected or selected. Okay. So what is the threshold value? That is 90. And if the value, the percentage of the mark the student is more than 90 or close to 90 or on the 90, then you will say he will take the admission. Else, the student will be rejected for the admission. So what you are doing? You are deciding something that is on the threshold value. Same in our mind, in our our mind is decided some threshold internally in the internally in the form of the biological manner. Then we will decide should we go or not. Sometimes you will confuse, oh, I should go or no, should we go. So at the time you are not deciding the appropriate option. That is my point. But in the machine, some activation function is required. Machine will take decision: should we move or not? Should we start or not? Should we move this task or not? So some activation is required. So Sigmoid function is best example for the activation functions. And what are the other activation functions? I will tell you while learning the neural network. So this is just idea about the sigmoid function. Okay. So that's why the in the graph z equal to wi xi plus y is written, and wi xi is the weight of the our input values, what input we are getting. So and from which we are getting input, that is represented by the x. I will tell you more detail about the neuron. Okay, don't worry. But practical as well. So far, do you have any doubt about the sigmoid function? Yes, tell me. Do you have any doubt to understand the sigmoid function?
No, sir.
So see, just let me just give me some summary. Sigmoid function is also known as activation function, and this activation function is applicable when we need to invoke our when it is required to invoke our neurons. Okay, so in the neural network, when the neurons are required to activate, so activation function will decide, and we have the various kind of activation function. Those are the 10H, ReLU, and Sigmoid. And which one is better? So definitely we will see after comparing its different activities. But Sigmoid function is better. Initial function will decide the activation. So that is the important part. So this is this idea about the Sigmoid function. In this slide, we have an example. I just put it over here for you betterment for the theoretical purpose, then you can understand. Now, we have two classes. One class belongs to dog class, another class belongs to the cat class. So our information, our data set is divided into different parts. There was a dog and cat. Okay, and other features also applicable over there. So our data set is just prepared following by the some features, and now we have the some predictor variables. So we can say independent variables and dependent variables. So we have the use data set. After putting the something or after putting the independent variables values or features values, now we are getting the value 0.7, suppose you are getting over here, and now we have decided the threshold values. Now you are getting 0.7. So you can say threshold value is smaller than the our input values or our outcomes value, that is y. So we can say now that should be dog. Why? Because we have labeled dog as a 1 and we have labeled cat as a 0. So definitely we can easily identify the input on the basis of input features. This is a dog. That is my point. And that is an important point. We need to understand logic regression play important role to classify your data. So that is a good example we have over here, and that is my point. Okay, so now tell me, any doubt in this example or any other problem you want to ask, please ask right now. Just tell me any other problem you are having. Yes, tell me. No doubt. Should I move to the next part?
Yes, sir.
Okay. So in the logic regression, in the mathematically, it is categorized into the various part as well. But 99% we will choose binary logic regression. So here I'm just explaining this concept in simple way. Binary logic regression is saying to us whenever we need to represent our information into two forms, either 0 or 1. It means we have only possible two outcomes. We have the only two possible outcomes. It is 0, 1, true, false, okay, or yes or no. Just like kind of this example. These are the various example of the binary logistic regression. As the name says, is binary. So two possible outcomes. What is it mean by the multinomial logistic regression? Multinomial logistic is saying us when we have the more than three possible outcomes, just like the category of the animals. So we have the cat, dog, or elephant. I'm taking any other example for the multinomial logistic regression, then you can understand over here. Suppose I need to filter the student in which class or in which year they belong to. So students year in which they are studying. Okay, so students years in which they are studying, I can easily classify based on the three different points: first, second year, and third year. Okay, so if I'm taking any input and after observing this point or after seeing the his or her enrollment number, I can say this student belong to the third student, this student belong to the first year. So that is a classification I can do. So when we have the three or more than three nominal values, so we can say this is known as the multinomial. Now here we don't have the two. Here we have the more than two. Okay, more than three or more than three. Okay, when we have the two, so we will consider into the binary. Suppose I am just talking about right now the first and second year student. So we have the two values only, first year and second year. So at the time, the such a logical regression can be identified as a binary logical regression. But what is the meaning of the ordinal logical regression? This is a simple example. It's saying to us, you can represent the information in form of some order, and that order could be 1, 2, 3, 4, 5, 6, A, B, C, D. Suppose I am just classifying the room number, okay, based on the floor. So on the based on the first floor, so I'm putting the one. So room number 101 belong to the first floor. Room number 102 belong to the first floor. So room number 101 to 1010, the rooms belong to the first floor. So I'm giving the uh, floor value that is one. Second, room number 201 to 2020, okay, 2020, or maybe the other values. So these rooms belong to the second floor. So if I'm just defining this kind of the category, maybe the 1, 2, 3, 4, 5, maybe the ABCD. So that is also known as the ordinal category, because I have some order 1, 2, 3, 4, 5. I don't have any specific order. I don't have the 3, 2, 4, 5. I have some order 1, 2, 3, 4, 5. So here the representation can be also identified by the 1, 2, 3. So this can be identified as a ordinal because it has an order one, first, second, third. Okay, so that is a good example. Here in the diagram, you can see binary, nominal, ordinal. So here we have some example you can see over here. So type of the logic derivation is basically necessary when we solve any problem. 99% or 99% I can say 99% most of the problems are based on the binary logic derivation. Sometimes we will see some problem with help of the multinomial and ordinal. So definitely don't worry. Based on the requirement, we will see all these things. First, we will try to solve our problem based on the binary logic derivation. So that the point we need to keep in mind. Okay. So this is the my point right now about the logic regression.